In previous session, we have studied partial differential equation, its classification, characteristics. After that, last two sessions we have spent on solving elliptical equation. Now, in today's session, we are going to cover another class of partial differential equation, that is parabolic equation. Parabolic partial differential equation. Now, how can you identify a parabolic partial differential equation? By computing the value for b square minus 4ac for the given partial differential equation. So if this value comes as a 0, then you will say that the given partial differential equation is it belongs to parabolic PDE. Okay. Now, after that, during the introduction, we have seen few examples of parabolic partial differential equation also. Okay, so let's see one of the example. Just imagine you are dealing with a rod, okay, a insulated rod, and it has been assumed that the heat is supplied from one end and there is a atmospheric temperature or cold junction onto another end. Okay, now due to this insulation, the conduction problems become only one dimensional. So that means the heat is going to flow in a single direction. Assume that this direction is x. Okay, now in earlier case, during our study of elliptical equation, we have seen the thermal distribution over a plate. So in that you had x and y direction. There were two parameters, two independent parameters, and you have calculated temperature at various location x and y. Okay, here u is nothing but temperature or any governing independent variable, sorry, dependent variable. Okay, so this u was depending on the location coordinates x and y. Now coming back to the parabolic equation, as you know that this is a partial differential equation, that means there will be two independent parameter. Okay, so one is x and where is another one? So for that, if you look at the problem statement, if you study the steady state conduction, it belongs to the elliptical parabolic equation. And if you are considering a transient state, that means there is a time change or time as a independent parameter. अगर आप ट्रांजिएंट स्टेट का एनालिसिस कर रहे हो, ट्रांजिएंट एनालिसिस कर रहे हो, so that means you have two independent parameter. You are considering x variable and t variable. Okay, so let me give you this example with simple language. आप क्या कर रहे हो, ये रॉड का थर्मल एनालिसिस कर रहे हो. You would like to get to know or compute temperature on this rod at various location. जो मैंने डॉट बनाए ना, वहां पे आपको टेम्परेचर फाइंड करना है. ओके, नाउ टू जनरलाइज दिस टी, इंस्टेड ऑफ टी आई यूज यू. ठीक है, जनरल बनाने के लिए. सो मुझे क्या करना है, u1 u2 u3 फाइंड करना है. ओके, नाउ दिस u1 u2 u3 अप टू un फाइंड करना है हमें टेम्परेचर्स. बट दिस टेम्परेचर्स we are going to find with respect to x and t. मीन्स व्हाट, आपने यहाँ पे टेम्परेचर दिया, एज्यूम करो मॉर्निंग में, यहाँ पे हीट सप्लाई करना चालू किया मॉर्निंग में, एंड यू आर मेजरिंग द टेम्परेचर इन द इवनिंग. सो दैट मीन्स you are having one more parameter to consider, that is time. Okay, so the heat is flowing in the x direction. You are measuring the temperature at various location in the x direction, but at various time steps. ओके आप दोपहर को भी चेक कर सकते हो या फिर आफ्टरनून में भी, सॉरी इन द इवनिंग ऑल्सो यू विल चेक दैट. सो in your governing equation you are dealing with two parameter, time along with location x. Okay, so if you look at the one dimensional heat conduction equation, the partial differential equation you will observe is dou u by dou t equal to c square into dou square u by dou x square, where u is a function of x comma t. X and T are the independent parameter and C square is the thermal diffusivity of the substance. Okay, so this is your case. So this is your parabolic partial differential equation. Okay, तो हमें क्या करना है, यहाँ पे ये टेम्परेचर फाइंड करना है एट वेरियस लोकेशन. दैट मीन्स ये जो गवर्निंग इक्वेशन है पार्शियल डिफरेंशियल इक्वेशन, उसको सॉल्व करना है. सॉल्व करके क्या मिलेगा आपको, डिफरेंट वैल्यूज ऑफ यू. Right, now we are not going to use conventional way to solve this partial differential equation. Instead we are going to deal with numerical method. Okay, now to solve parabolic partial differential equation there are plenty of methods available. These methods are grouped in two types, implicit form and explicit form. Okay, now there are again implicit or explicit में भी बहुत सारे types है. Due to the scope, limited scope of our syllabus, we are going to go with only one method. Okay, the method is called as the Crank-Nicolson method, which belongs to implicit form. Now instead of worrying about remaining part, we have chosen to get the best possible numerical method to solve parabolic equation. सबसे माने accurate computationally efficient method is the Crank-Nicolson method. So we will focus only on that. So in the next slide there is some derivation part. Ultimately in most of the book also they have skipped the derivation, but I'll just give you the idea how they came up with this formula. You had that parabolic equation dou u by dou t equal to c square dou square u by dou x square. This was your governing equation or parabolic partial differential equation. Now as we are using numerical method to solve this differential equation is converted into a simple form by applying Newton's central difference method. Okay, now this method, इसका भाई हमने already देखा है, देखो in interpolation. In interpolation we have learned one Lagrange's interpolation method and second one was Newton forward difference method. Now Newton's interpolation methods, there are three types. One was forward difference method जो हमने सीखा, और हमने जो skip किया that was Newton's central difference method and backward difference method. So if you implement Newton's central difference method and you solve this partial differential equation, okay, so ultimately you are going to come across this kind of equation. Okay, now as we have done earlier, the derivation is skipped. Just we need to implement the formula to get the value. Okay, so for your solution you need to remember this formula. Okay, now in the next slide I'll show you the easier version of this formula which will be easy for student to implement and also to remember. Okay, now just as we are discussing about this formula, let's understand what that formula is and what are the variables available here. Okay, So to understand it clearly, take the example of that earlier insulated bar. Okay, assume that this is heated junction. Okay, and onto the right hand side thoda cold junction hai. Okay, and we are interested to find the temperature after some time, after let's say 2 days. Okay, so you have supplied a heat and there is a cold junction, and you are going to measure or you are going to compute temperature at 3 locations. Okay, for the sake of simplicity we'll take only 3 locations because we have implemented finite difference approach. जो भी बार होगा उसको टुकड़े कर दिए हमने. We have created a grid. As this is 1D only, तो एक ही grid बनेगी like this. Node number 1, node number 2, node number 3. Okay, so instead of numbering this, I'll say this is a left hand node, this is a central node, and this one is a right hand node, a right wala node. Okay, so assume करो आज हमने टेम्परेचर मेजर किया और कंप्यूट किया T at initial, मतलब T at 0. Okay, so that temperature is temperature of left hand node कब initially. Okay, so similarly central node का compute किया for initial condition, right hand condition initially. Okay, then we are going to spend 2 days. After 2 days again at T at 2 days, we are going to again compute the temperature, we are going to predict the temperature. Now that temperature will be obviously different than the current temperature. Okay, today's temperature. So again there will be T of left hand side tomorrow after 2 days, central after 2 days, right hand side after 2 days. Okay, so now there are 3 variables for each location. Location matlab aaj and 2 days after. Okay, now this is represented, जो मैंने concept अभी आपको बताया ना, it is actually represented mathematically, graphically here in this figure. Okay, so let's see that figure. These temperature nodes. Okay, so these nodes जो मैंने highlight किए, these are at initial condition. Okay, at initial मतलब assume करो time equal to 0. ठीक है, so आपने central node लिया I, j. I stands for x, j depending on t. J stands for time. So j, j, j मतलब एक ही दिन में. Okay, t equal to 0. I मतलब central, I minus 1 मतलब left hand side, I plus 1 मतलब right hand side. Okay, so this is the temperature U at 3 locations today. Okay, at t equal to 0. Then in the graph time has been spent. कितना time spent किया हमने? K amount of time is spent, or it is called as a time step. Okay, so for our example it was 2 days. So on a graph again it has been plotted कि by j plus 1, that is j plus k, or after k. Again at the same level, that is on a right hand side, center and left hand side, the temperature is computed, U is computed. Okay, now if we go back to this formula, here you will see U I minus 1 comma j minus 1. Okay, so I minus 1 comma j, j plus 1. So that is this corner, this point. So temperature at that point into minus alpha plus 2 times 2 alpha, 2 plus 2 alpha times u I comma j plus 1, मतलब ये सेंट्रल वाला पॉइंट, माइनस अल्फा इंटू u I plus 1 comma j plus 1, मतलब ये राइट हैंड साइड वाला पॉइंट. ओके, सो फर्स्ट पार्ट, फर्स्ट टर्म or left hand term of that equation belongs to the top, ठीक है, and right hand side see j that means bottom wale. Okay, so I minus 1 comma j मतलब bottom left, I comma j central, I plus 1 comma j right hand side वाला. Okay, now u आपको समझ में आया, बट यू फाइंड दैट यहाँ पे और एक टर्म है, वेरिएबल इज अल्फा. Alpha. Alpha is calculated as kc square divided by h. Okay, so I guess this is wrong. Kc square by h, where c square is what? Thermal diffusivity. This is material property. Okay, now c square will be given in the problem statement directly. Now k and h. K is the time step and h is the space step or distance step, dimension step, मतलब step in x direction. To understand clearly, see h का जो यूनिट होगा वो होगा मीटर, सेंटीमीटर, वगैरह. ओके, मतलब आप लोकेशन में देख रहे हो, उसका स्टेप ले रहे हो कि भाई पहला लोकेशन और दूसरा लोकेशन के बीच में डिस्टेंस कितना है, तो 10 सेंटीमीटर, 20 सेंटीमीटर. That is your h value. K is a time step. इसका यूनिट होगा सेकंड, मिनट्स, आवर्स, डेज, ईयर्स एटसेट्रा. ओके, सो टाइम मेजरमेंट होगा. सो के मतलब आपको टेम्परेचर कंप्यूट करना है, बट इन बिटवीन व्हाट इंटरवल, आफ्टर विच टाइम, आफ्टर हाउ मच टाइम. ओके, सो 1 आवर के बाद या 2 आवर के बाद एंड सो ऑन. सो दैट इज योर ट्रांजिएंट एनालिसिस. ओके, टाइम डिपेंडेंट एनालिसिस कर रहे हो. सो के is a time step, h is a normal step, distance wali step. So this is your formula. Formula आपको समझ में आया होगा, but I'll suggest you, I'll recommend you to not use the given formula right now. जो मैं आपको next slide में दिखाऊंगा, try to use that one because that I feel is a easier one, easier approach. Okay, now for the next slide, this image is flipped, चेंज किया है मैंने, because it will be easier for you to solve the numerical. Okay, now in this figure change क्या किया मैंने, टाइम. इंस्टेड ऑफ फॉरवर्ड टाइम मैंने डाउनवर्ड टाइम लिया है. the reason is when you solve a numerical you are going to prepare a table. Okay, now in that table the time is going to start with 0 and going to change in a downward direction, मतलब 1 मिनट के बाद, 2 मिनट के बाद, 3 मिनट के बाद एटसेट्रा. तो आपका जो डायरेक्शन होगा टी का, डाउनवर्ड होगा इन द टेबल. Even though we know that if you plot a graph, t should be positive, right? Mathematically it should be go like this, but this will not help us in the solution. So मैंने क्या किया, चेंज कर दिया, डाउनवर्ड ले लिया. Because it aligns with the table format. You will get to know, you will realize this when we go for the solution. Okay, so only one change किया है मैंने, t नीचे ले लिया. Now these are the nodes. Okay, now this is at t equal to 0 and this is at t at some time. Okay, after some time. Now this distance is k. K will be in second, minute, hours. This space is h. h मतलब आपका लेंथ होगा, डिस्टेंस, सेंटीमीटर, वगैरह. Okay, now so your bar, insulated bar is something like this. This is central point, right? So it is denoted at u, assume करो temperature, u e of top central node, right? This is top nodes and these are bottom nodes. these are bottom nodes. So all top nodes are denoted as UT, UT, UT. Okay, and based on the location, UTC, UTC, top central node, top right hand node, top left hand node. Okay, similarly, bottom central node, bottom right hand node, bottom left hand node. Okay, so try to understand this. If you understand this figure, आगे वाला part easy जाएगा. Okay, now that formula. Okay, so formula you have to remember that formula. Now how to write that formula? Here it is. On to the left hand side you have bottom terms, and on to right hand side you have top nodes. Okay, so थोड़ा simplify किया है. On bottom start with a negative sign, negative alpha into summation of values at left hand and right hand node, plus 2 times, sorry, 2 plus 2 alpha times central node. Okay, then equal to, अब साइन चेंज करना है, अल्फा का साइन चेंज करना है. हियर इट वाज नेगेटिव, सो यहाँ पे बन गया पॉजिटिव. Okay, now here alpha was positive, it becomes negative onto the right hand side. Okay, almost बाकी का सब सेम है. See, bottom left plus bottom right equal to, यहाँ पे इधर देखो, left hand top, right hand top, bottom central, top central. Okay, so start with negative alpha. यहाँ पे 2 plus 2 alpha, remember this. And when you go for right hand side, top variable लगेंगे आपको, change the sign of alpha, यहाँ पे positive alpha, and यहाँ पे 2 plus की जगह 2 minus 2 alpha. So this is your formula. Now somehow you need to remember this formula. Okay, so I request all of you to take a screenshot of this image, this slide. Keep it handy with you. Whenever you solve a numerical of parabolic partial differential equation using Crank-Nicolson method, keep it ready with you. ये आपको the iteration part will be easier for you, or calculation part will be easier. Now this formula will not be present in any books. आपको वो I and J वाला formula मिल जाएगा easily. Okay. So let's go on and solve one numerical. ठीक है, थोड़ा complicated लगेगा, but do the practice for this method. Partial differential equation as it is, they are little complicated, but उसका application बहुत ज़्यादा है. So please focus on the solution. थोड़ा बहुत practice करोगे, it will be simpler then. ठीक है, आपको आगे simple लगेगा. Okay, so read the problem statement carefully. Each of the term is important for us, and इसका हर एक का एक meaning रहता है, physical meaning है. Okay, so let's look at this example. The partial differential equation is given to you, dou u by dou t. Here make a correction, dou u by dou t equal to dou square u by dou x square. Okay, so this is your governing equation. Now if you compare that equation with heat conduction problem, you have dou u by dou t equal to c square dou square u by dou x square. So this was your one dimensional heat conduction equation. As they have told you to go for Crank-Nicolson method, मतलब ये जो partial differential equation है वो parabolic ही है, Crank-Nicolson वहीं पे implement होता है. Okay, now if we compare these two equation, you will come to know that c square का value कितना आया है, 1. Now see, यहाँ पे देखो dou u by dou t same, dou square u by dou x square, same. dou square u divided by dou x square multiply by c square, और यहाँ पे multiply by 1, कुछ नहीं है मतलब 1 है, so that means c square is equal to 1. Okay, so on your given data you will write down कि भाई c square equal to 1 आया है. After that you know x is in the limit 0 to 5. इसका मतलब क्या है, x 0 to 5 में vary हो रहा है. Physical meaning, assume that this is a rod, insulated rod, x is in this direction, so that means you are going to measure the or compute the temperature at x equal to 0, x equal to 5. that 5 might be in meters, so 5 meter पे एक node होगा आपका. In between there are plenty of x. How many? Let's see. Compute u for time step with h equal to 1. Okay, so h is equal to 1. h मतलब distance between x1 and x2, x2 and x3, right? so मतलब ये आकर आपका पॉइंट है 0. ओके, सो 0 to 5 जाना है आपको विथ स्टेप साइज इक्वल टू 1. सो यहाँ से आप 1 मीटर मेजर करोगे, फर्स्ट पॉइंट मिल जाएगा. 1 मीटर मेजर करोगे, सेकंड पॉइंट, थर्ड पॉइंट एंड फोर्थ पॉइंट, एंड लास्ट इज योर 5. ओके, सो x 0 1 2 3 4 5 ऐसे वैरी होने वाला है, और यहाँ पे आपको टेम्परेचर्स मेजर करने एट दीज नोड्स 1 2 3 4 5. ओके, now another thing they have mentioned is t greater than 0. t मतलब टाइम, ओके, इक्वल टू एंड ग्रेटर देन 0. इसका फिजिकल इंटरप्रिटेशन क्या है कि भाई टाइम जो होगा, एक तो इनिशियल कंडीशन दैट इज t इक्वल टू 0 होगा, एंड t मोर देन 0 मतलब आफ्टर, नॉट बिफोर. इफ t लेस देन 0 होता तो पास्ट टेंस में हो जाता, ओके, निगेटिव डायरेक्शन में हो जाता. बट इट इज ग्रेटर देन 0 मतलब पॉजिटिव, फ्यूचर में आपको प्रिडिक्ट करना है. given that u equal to u x comma 0 equal to 0, 20, u 0 comma t equal to 0, u 5 comma t equal to 100. okay, तो इंफॉर्मेशन बहुत सारे कंडीशन, these conditions are called as a boundary condition. these are at boundaries. for example, if you look at this number u 0 comma t मतलब u at 0 location, मतलब ये वाला लोकेशन, at time t the temperature is 0, so at this point temperature is equal to 0. okay, second thing, इसका देखो, u at 5 of time t equal to 100, मतलब ये जो 5 वाला पॉइंट है इसका टेम्परेचर 100 रहने वाला है at any time t. okay, at time t equal to 100. okay, then u x comma 0 equal to 20 means at initial condition at time equal to 0, जब आपने सिर्फ स्टार्ट किया है, यहाँ पे आपने हीट सप्लाई करना चालू किया और ये आपका कोल्ड जंक्शन है. at initial condition if you measure the temperature at these location 1 2 3 and 4, the temperature obtained is 20 degree. ठीक है, सो स्टार्टिंग में देखो 0 20 20 20 20 एंड 100 टेम्परेचर है. आफ्टर सम टाइम the temperatures are 0 and we don't know after some time how many temperature or how much is the temperature, but at the final location again the temperature is 100. so sorry, here the heat supplied and this is the cold junction. I told you other way around. so this is a physical interpretation. okay, हमें इतना ज्यादा कुछ नहीं करना, we are our aim is to solve the numerical. so let's start with the solution. so h is given to you. सबसे पहले आप क्या कंप्यूट करोगे, तो अल्फा, अल्फा इक्वल, ओके, सौरभ प्लीज. so alpha equal to k times c square divided by h. okay, सो k कितना है, टाइम स्टेप पता नहीं है, उन्होंने दिया ही नहीं है। h कितना है देखो 1, सो h इज इक्वल टू 1, c स्क्वायर इज इक्वल टू 1, सो व्हाट वी गॉट, अल्फा इक्वल टू k। ठीक है, नाउ यू कैन एज्यूम एनीथिंग और सी द कंप्यूट u फॉर द टाइम स्टेप। ओके, जनरली यहाँ पे टाइम स्टेप दिया जाता है, नहीं दिया, they might forgot to mention, we will assume it's a one time step, compute u for one time step, ऐसा कुछ तो भी होगा। ओके, सो मतलब k is equal to 1, so this k might be given, it might be present in the problem statement, if not assume k equal to 1, assume कि भाई टाइम स्टेप जो होगा वो 1 यूनिट होगा। ओके, सो यू गॉट अल्फा इक्वल टू 1। ओके, सो जब भी आप एजम्पशन अगर करना होगा ना तो डायरेक्टली एज्यूम करो अल्फा इक्वल टू 1। इफ के एच आर नॉट गिवन टू यू, सी स्क्वायर अगर दिया नहीं है तो डायरेक्टली यूज अल्फा इक्वल टू 1, क्योंकि आगे वाला फॉर्मूला बहुत ही इजी हो जाता है। सो लेट्स स्टार्ट विद द सॉल्यूशन। सी स्क्वायर 1, एच इक्वल टू 1, टेकिंग अल्फा इक्वल टू 1, के इक्वल टू 1 मिल गया हमें। ओके, नाउ वी आर गोइंग टू प्रिपेयर अ टेबल। ओके, नाउ प्लीज अंडरस्टैंड द मेथड ऑफ ऑब्टेनिंग टेबल। ये सबसे कॉम्प्लिकेटेड या लॉजिकल पार्ट है, इसके आगे वाला पार्ट बहुत ही इजी है। सो लेट्स लुक एट दिस टेबल। सो टेबल कैसे है देखो, जो मैंने फिजिकली दिखाया था ना, फिजिकल इंटरप्रिटेशन ऑफ द प्रॉब्लम स्टेटमेंट, सेम थिंग वी आर गोइंग टू राइट इन हियर इन द टेबल। सो एज्यूम करो योर x इज वेरिंग इन दिस डायरेक्शन। ठीक है, कॉलम्स में x वेरी हो रहा है और रोज में t वेरी हो रहा है, टाइम वेरी हो रहा है। ओके, सो x वेरी कैसे होता है आपको पता है, 0, 0 प्लस 1, h इज इक्वल टू 1, राइट। सो 0 प्लस 1 1, 1 प्लस 1 2, 2 प्लस 1 3, 4 एंड लास्ट वैल्यू 5, क्योंकि हमें स्टार्ट करना है 0 से, एंड करना है 5 पे, इन बिटवीन h1, राइट। नाउ t, टाइम, टाइम स्टार्ट हो रहा है 0 से, राइट, t इक्वल टू 0 एंड k इज 1, तो k ऐड करो टाइम में 1। नाउ दैट 1 माइट बी आवर, मिनट, डे, एनीथिंग, वी डोंट नो, इट इज नॉट स्पेसिफाइड। ठीक है, सो t इज 0 एंड 1। नाउ कमिंग बैक टू द गिवन कंडीशन, जो बाउंड्री कंडीशन है, अब उसका यूज करने वाले हम। Already I have told you this, but again there might be some confusion. So let's look at this numbers or first boundary condition u 0 comma t. Okay, so that means इसका meaning क्या है, 0 sorry u, temperature at location 0, at location 0 is 0, so always this temperature is 0, we are maintaining that. At boundary the temperature is 0, and at other boundary, heated one, that is 5, the temperature is 100 always. Okay, because of this condition. ठीक है, now remaining part u x comma 0. okay, now इसका 0 का मतलब क्या है, in this row, right, हमने कॉलम पे देखा था अभी। now for x comma 0, so for initial condition at various x values the temperature is 20, इनिशियल कंडीशन में टेम्परेचर्स आर 20, बिकॉज अब देखो बाउंड्री में तो 0 दिया है और सेकंड बाउंड्री में 100 दिया है, तो बचे वाले जब पॉइंट्स है रिमेनिंग x, उसका टेम्परेचर कितना होगा, 20। ओके, सो दिस इज योर इनिशियल कंडीशन, आपका जो रॉड होगा या पाइप है उसका at initial condition all the temperatures are known to us. Okay, now after t time, after some time t, we would like to compute remaining temperature. Okay, so we know boundary में 0 है and 100 है, but बीच में क्या है, so just we will use term u1, u2, U3 and U4, that U4 to represent temperature at 1, 2, 3, 4 after some time. Okay, so I hope all of you have understood the table, because table ही थोड़ा complicated लगेगा. बाकी सब easy part है. Okay, so let's proceed with the solution now. You know, this was the figure. मैंने बोला था आपको, ये copy कर लो, screenshot ले लो. And the formula was like this. Okay, now we're going to put alpha equal to 1, because assumption किया था alpha 1 है, तो यहाँ पे 1 put करते. Then you will find that this is 1, this is 1, so 2 into 2, sorry, 2 plus 2 becomes 4, 1, 2 minus 2 alpha, alpha is 1, 2 minus 2 0. Okay, so this got cancelled. So ultimately you are going to get the equation something like this. थोड़े simplified version है. And if you look at this formula, it's similar to your diagonal formula जो हमने लास्ट वीक में, सॉरी लास्ट लेक्चर में देखा था ना. सी this UTC, okay, this top central point got cancelled due to this 2 minus 2 0. But देखो, if you would like to calculate this central bottom point, it's the average of these 4 points, remaining 4 points. See, 4 times UBC equal to summation of all these data points. That's it. Okay, so you can take an average, but मैंने directly average वाला formula नहीं लिखा, because there might be some confusion. Standard formula, फिर diagonal formula. So इससे अच्छा है क्या करो? You can use this formula. 4 times central node is equal to summation of left and right nodes, all left and all right nodes. ठीक है, या neighboring left and right nodes. Okay, so this is your formula. Now the problem becomes very easy. Now if you look at this first part, u1 के लिए, okay, so for calculating u1, I'm going to write the formula. So u1 is the bottom central part, bottom central point. So formula becomes u 4 into u bc, that is u1, 4 u1 equal to summation of left hand वाला node, right hand वाला node, so 0 plus u2 plus ऊपर वाला left, ऊपर वाला right, 0 plus 20. That's it. Okay, so you got one equation, that u2 4u1 minus u2 equal to 20. So ये आपका एक इक्वेशन नंबर 1 बन गया. Okay, similarly go for u2 again. So there might be some confusion, so I'm going to repeat the procedure. Now focus, if you would like to calculate u2, for u2 I'll write the equation for u2 assuming the central bottom point. So 4 times u2 equal to summation of left वाला point, right वाला point, top left, top right, u1 plus u3 plus 20 plus 20. Okay, so what you got here, u1 minus 4 u2 plus u3 equal to minus 20. Okay, so मैंने क्या किया, ये इधर लेके गया, and this total onto the right hand side. Okay, so you got this equation, second equation. Similarly you can compute for u3. So u3 will become 4 u3 equal to u2 plus u4 plus 40. Okay, then u4 के लिए u4 times u4 will be equal to u3 plus 100 plus 20 plus 100. So आपका इक्वेशन क्या बनेगा, 4u4 equal to u3 220. Okay, so this kind of equation you will obtain. Now after getting these four equation, now look at the four equation, and how many unknowns are there? Four unknown, u1, u2, u3 and u4. Four unknown, four equation. You can apply any method, you can do the manipulation of equation and compute u1, u2, u3, u4. That's it. So that will be the end of your solution. Okay, क्योंकि हमारा एम ही यही था कि वेरियस टेम्परेचर या यू फाइंड करना है हमें. Okay, so by somehow solve this four set of equation, ultimately you are going to get this answer. Okay, so any doubt?